after 11 minutes. Woo! Okay, so this problem was solved by 98 teams before freeze, maybe or not after freeze, we can't know. I don't, okay. And then, like, what should we do? Well, we should compare two probabilities. The probability that Alice wins and the probability that Bob wins. And in practice, I mean, well, it turns out that, I mean, comparing these, I mean, computing the probabilities is hard, but comparing them is not hard, okay. It's just because your distribution laws for the totals of the dice, I mean, they are symmetric around their expected value, okay. And so basically what you should just do is compare the expected values of the score of Alice and the score of Bob. And so the expected value when I have like a six faces die is just I have, well, the average of 1, 2, 3, 4, 5, and 6. And so in particular, it's the same as the average of 1 and the maximum. So that's why it's like 1 plus S over 2. Okay. And so now I take the sum of the average per dice, and it gives me the average score for Alice, the average score for Bob, and then I just have to compare those two half integers. Okay. So congratulations to those teams, which were like quite many, who solved this problem, because if I give it in my university, I think that, well, this is the number of death letters I will get after the exam, okay? So thank you all for being so brave and good. Okay. And next is programming trampoline-athlon. C'est moi aussi? And so I do it, but this problem was by Nofar. Okay. So it was solved first by EPFL Olympiads 1. Okay. It has, well, approximately as many teams that solved it. Okay. Well, you can jump and code, and this is like you have one code per one ordinateur per team, so that's cool. And then, well, you just find medalists. So, well, you can compute the score of a team, and then once you have computed the scores of each team, you should just find the 3 teams with the best scores, and maybe a bit more if you have ties. Okay. So what you can do is just you sort and then you output the best teams, and so you register the score of the 3rd team, and then like if my score is at least this one, then I'm a medalist. Okay. You are not obliged to sort them because you could just, I mean, find the first and find the second and find the 3rd one. So it gives you a linear time instead of n log n, but we don't really care for this problem. Okay. Okay, and now we'll have a nice view.
Okay, so nicest view was solved by 38 teams only before freeze, and first solved after 17 minutes by Heroes of the Sea. Congratulations to them. All right. So the problem was to find the longest horizontal line between 2 points on a path. The first version of the task was a bit ambiguous because we thought that you all knew that we cannot see through mountains, so we wanted to clarify in the second version. So the solution is first to know that the nicest view is obtained either at a milestone or looking at a milestone. So if you are below a milestone, then you can always go a bit higher and you have a nicer view. So what you have to do is to compute the best view you can have at each milestone, looking either left or right. So at each milestone, you have to remember the previous milestone that are higher than this one, and that you can still see. So it's a stack of decreasing milestones. So it's pretty standard thing with stacks. And then you have to compute the length, which is not that hard, but you had to use fractions, and it causes a lot of troubles to many of you. That's why you could see the number of wrong answers. Of course, you have to do it in both ways. So, for example, on the example, you maintain the stack of milestone that you can still see, and then you compute the length, and that's it. And then you do the same, going from right to left, and you take the maximum of the two values, and that's it.
Okay, the next problem was a broken trophy problem. It was proposed by Vincent. And, well, you've broken your trophy, so you have a set of tiles, they're rectangular, and you have to put them back into a 3x n rectangle. And this looks like all these classic Pantomino tiling puzzles with, you have simpler tiles, you know, they're all rectangular and you just have 6 different shapes, but you can have a lot of them. This looks a bit daunting, but there is in fact an easy solution. You can always assemble your tiles following this kind of pattern. So of course, you know, the 3x3, you can just get rid of them. There is no smart way to handle them. The 2x3, you can put them like this. There is no point in putting them flatly because you know, you would have to fill up with something and you could always turn. And maybe the difficulty is to convince yourself that the 2x2s can be put out this way. Actually, we did not ask for a proof that it's always possible to do like that. You know, just a program that would give the answer would be fine. A proof would look something, you know, it's case analysis. It would look a bit something like this. Maybe the crux is that if you cannot finish your lines of 2x2s because there is missing something, then it means that the number of tiles that you have won't be a multiple of 3, and it's a situation that's impossible. Okay, so that's it for this problem. And congratulations to the teams who solved it.
Okay, so this problem is card game. It was also a proposal of SNOFA. So it was solved after 20 minutes by Università di Pisa. So congratulations. So you were given single cards. So each card has a suit and a number, and you had to sort them using the minimum required number of moves. Okay, so the solution expected is in n log n. So first, to solve this, first imagine that the order of the different suits is actually fixed. Then you can see that the cards that do not move in an optimal solution actually are already sorted. And conversely, if you are given a set of cards which you said, which you know do not have to move, you can easily find a solution which does not move this card. So the problem is completely equivalent if you fix the ordering to a problem of finding the longest increasing subsequence, which is known to be doable in n log n. Okay, so the problem is that there are multiple possible orderings, but actually not that much. Since you only have to say in which order you want to put the different suits, well, actually there are only 4 different suits, so there are only 24 different orders. So simply you do 24 longest increasing subsequences, and you take the best one. Okay, now it's team selection.
So team selection was first solved by the team Volterra GNG. So congrats. And so the problem was to repeatedly find and extract the kth element among an ordered list of elements. The expected solution was of complexity n log n, and it goes as follows. So for each element, you can store a 0 or a 1 to denote whether it was already chosen. Then you maintain a segment tree on these elements. And then given a k, you traverse the segment tree efficiently to find the kth non-zero element in log n time. And then you set it to 0 and update the segment tree in log n time as well. So there are a couple of solutions that we either saw in the summations or that we thought about. The first one that we've seen a lot was summations that are using some order statistics tree from C++. So it was also an n log n solution, but unfortunately it was too slow by a factor about 3 in practice on the test cases. So they were refused. Another solution was to run a binary search on the segment tree for each choice of the players, so which leads to a slightly worse n log n squared solution. But some of those solutions were accepted because they were pretty efficient in practice. There's another solution which goes as follows, which is to maintain an array of the remaining elements and an array of picked indices of those elements, and then update this array every square root of n queries, which leads to a total complexity of n to the power of 3 over 2. It was too slow, but surprisingly not by too much, only by a factor of 3. And finally, of course, the naive solution, the naive n squared solution was also far too slow.
So supporting everyone was solved by 24 teams before freeze, and first solved after 35 minutes by Exotic from École Polytechnique. Congratulations. So in this problem, we just wanted to get the minimum number of crayons and pins we could to represent every country to the event we're going for. And the solution was cubic time and quadratic space, where if we represent the link between countries and the colors in the flag as a graph, it's a bipartite graph with n plus m vertex and at most n times m edges. And then this translates to the minimum vertex cover problem. And for bipartite graph, we can use Koenig's theorems to show that it's equivalent to maximal matching, and it's doable in this time. Congratulations to all teams.
Okay, so Olympic goodies was solved by, I think that's half of the teams, right? 55 teams before freeze. And first solved, let me say, surprisingly late, after 7 minutes, sorry, by the famous doublethink from ETH Zurich. Well done, guys. Now, this problem was about placing strictly positive integer weights on a subset that is possibly not all sum of the edges of the tree, such that the sum of all these weights equals to some given largish integer p. And then, importantly, we want to minimize the cost, the length of the maximum, the most expensive path in the tree. And so one provably correct solution to this is to actually place all the weights only on leaf edges, that is, edges that are incident to leaves, and furthermore try to place these weights as uniformly as possible, if you wish, which in practice means that we do the integer division of p by the number of leaves, and then we assign the result of this division to each leaf edge, and then we take the remainder, the modulo of the division, and then we dispatch this as a +1 on a sum of the remaining leaves, right? And so accordingly, you would have either the result of the division or this thing +1 on all the leaf edges, which means that the result, the length of the of the longest, the cost of the longest path will be twice the result of the division if p is a multiple of the number of leaves, or this thing plus 1 if the modulo is 1, or this thing plus 2, right, if the modulo is greater or equal than 2. Now, this being said, I guess that if you have the right intuition, that is that, you know, a longest path must go through 2 leaves, and that, you know, this thing of uniformly distributing weights lowers as much as possible the cost of the longest path, then this becomes actually a very easy problem, right? I mean, you write like 10 lines of code, and then you throw it, you know, into dump judge. Well, you anxiously wait for like 5 to 10 minutes, but then you get the result, and big joy, you passed all the tests. And there's just one thing to it, is that actually I know, I have been a contestant myself, and I know that no one bothers writing proofs, right, during SWERC, but I actually dare you guys, I know there's a lot of you who solved this, to try to prove that this solution is correct. I can give you my email address if you want to send me your proofs. And one other thing is that, well, a sample was designed a bit as misleading in an attempt to harden up a bit the problem. But to be honest, I have not actually analyzed whether there are solutions that may systematically involve, you know, some other weight placement. So if you guys coded something that, you know, doesn't resemble to this and passed all the tests, I'm really curious about that as well. Thank you very much, and congrats to everyone who solved goodies.
Hello. So Metro Quiz was a problem proposed by Raphael. You have a metro map, and one player thinks of a random line, and the other must ask questions to find out which line it is, and you have to minimize the expected number of questions. So it's actually a classic dynamic programming problem. You go through the tree, and at each step in the tree, you try to see which station you should ask about. And so you go through all of them and you minimize. The state in this solution is twofold. First, you have the list of stations you have asked questions about already. So that's a bit set. And the second is, given these questions, which ones were actually answered as positive or negative. And actually, you can convince yourselves that the state is not as big as it seems. So naively, it's 3 to the power of n, because each question either was not asked about, or positively, or asked about negatively. But actually, when you look at a given distribution of the questions, so the first state, the possible values are just the number of lines. So it's m times 2 to the power of n. Sorry, what they do? So actually, at each step, you are at a node in the tree, and you go through every station, I, in my example, and you do either there's an hypothesis that the answer will be yes, or it will be no. And you have to multiply that by the probability of that happening. So you need to count the number of possible lines that will still match, and to compute the probability. There was one trick, was that pre-computing all the probabilities is actually slower than doing it on demand, unless implemented very efficiently. I saw it once, because the hash table becomes way too large. That's it.
Hello. So I'm going to be presenting flag performance. Flag performance was solved by just 2 teams before freeze. So it was first solved by Exotic from École Polytechnique after 142 minutes, so congratulations. So the problem, if we state it more simply, is in how many ways can you sort an array, which is actually permutation, so no 2 entries are equal, of length n with case swaps, so you swap entries, yes? So that's the question. And for the solution, it's going to be a dynamic programming. Of course, if the states were the permutations, that would be too much because n goes up to 30. So 30 factorial, you would never end. And so the first trick you have to think about is that the cycle decomposition of your permutation is actually enough to solve your problem. Well, why? So here's the cycle decomposition. So it means if in position 2 you have a 1, so 2 goes to 1, then you look again and you create the cycles given by this where it goes in each entry. And you have a decomposition, which is the cycle decomposition of the permutation. And here you see that I didn't put the labels for the numbers inside, because we don't need that to know if it's the identity or not. If it were the identity, we'll just have n loops. Yeah? So that's enough information to know if it's the identity. And the point there is that the number of such cycle decompositions, if you don't look at the labels inside, is quite small. That's what the integer partitions, so in how many ways you can decompose a number, for example, there, 15, as a sum of integers. So the cycle decomposition there on the top corresponds to 7, the length of the first cycle, 4, 2, and 1. Yeah? And that gives you 15. And the number of integer partitions is much smaller. So for 30, you have 5,600 or more or less. Yes? And so that becomes doable. But then, of course, you want to solve your problem for many permutations, not just for one. We were giving you 10,000, yes? And there we saw in your solutions many, let's say, innovative ways to do that we didn't expect. So what we were expecting is this solution in which you pre-solve it for every possible cycle decomposition. So to do that, instead of going from the permutation to the identity, you do the opposite because you can. You go from the identity to every permutation. Then the only problem is that you must renormalize everything because each permutation with the same cycle decomposition, let's say, contributes the same quantity. Yeah, so it must be renormalized. There were quite nice solutions to this problem, so that I was quite happy about. And, and congratulations to all those who solved it. Let's see how many.
Anything? Okay, so next problem is favorite dish. So it's first solved after 148 minutes by ETH Zurich. And congratulations. So this problem is to calculate each person's favorite dish based on their weights and the scores. So when you look at the sample one, it's like not ordered. But if we sort the persons by their weight on the taste, you look at the first table, then you will see that every dish, you see every column, which is every dish, is an ascending or descending sequence. Okay, then we again sort the dishes by the first person's score. So different columns, we sort the columns by the first person's score. Okay, with that, for every dish, the score looks like an ascending or descending polyline. So it has 4 dishes, like yellow, red, blue, and gray. So every color is a dish. And every dish is a polyline, ascending or descending. And then we maintain a list of the current highest score. So we add the polyline, I means every dish, one by one. We add dish one by one. So when we add a new dish, we update the H list is short for list of current highest score. So we maintain the H list by every time when we add a new dish. How do we do that? We can prove that when we add a new line, there are at most one intersection. So with some binary search, we can update the new H list in log n time. That's how we finally do this algorithm in log n and m plus m log m. And alternatively, because when I proposed this problem, actually I haven't worked on computational geometry for a decade. And when I proposed this problem, other people in the jury all told me that, oh, okay, this can be solved with convex hull model. Maybe actually it's equivalent finally, but actually, even you don't know anything of computational geometry, you can solve this problem. Yeah, next one.
Okay, so the next problem is break a leg, the infamous geometry problem, and it was not solved before freeze. So as you can see, there have been quite a few submissions, but yeah. Okay, so to solve this problem, we do it in 3 steps, which are as equally important. The first one is that, okay, so the problem consisted in given a non-crossing polygon, counting how many triple of vertices were such that the center of mass of the polygon lies strictly inside the triangle which is vertices form. So, to solve this problem, first you need to compute the center of mass of the polygon, which is non-trivial. So, if I give you a triangulation of the polygon, it's actually easy, because then you simply compute the center of mass of each triangle, and you simply take the barycenter weighted by the area of the triangle. So this works. If you had the triangulation for non-crossing polygon in your notebook, congratulations. But actually, this was not necessary, because it's not easy to implement. You can simply use any sign triangulation. So if you have a sign triangulation, which means that you have negative and positive triangles, then you can do the same trick, putting a negative weight for triangles which are negatives, and this also works. So, and to obtain a sign triangulation, you can simply fix one vertex, consider every edge that is not adjacent to this vertex, and see if you consider the triangle this is formed with this vertex, you either count it positively if it goes clockwise, or negatively if it goes counterclockwise, and you obtain such a triangulation. Okay. So when you obtain this, you have the center of mass, and then you can get to the heart of the problem, which is solving the problem. So the important thing to understand is that once you have the center of mass, for any other point in the polygon, if you either reduce or diminish the distance to the center of mass while keeping the same angle, it does not modify the solution. What it means is that now you only need to count the number of points, of triple of points, such that if you take the angle between 2 of these points and the center of mass, you will never have an angle which is more than pi. Okay, so this may not be clear, so I've made a small example. So suppose you have this polygon. So believe me that the center of mass is somewhere around this. So you compute the rays like this. Once you have the rays, you order them, let's say counterclockwise. It does not matter. And you start, okay, you order them counterclockwise. You have a pointer on one vertex, on one point, like this one. You have a second pointer on the first vertex of the first point, which is to the left of this point relative to the center of mass. And simply, you know that now you can exclude all the triangles that are formed with this vertex and the vertex that are after this green vertex. Okay. So you have forbidden some triangles. Then you simply push this pointer. So you also need to push the green pointer so that you also have the thing that this green pointer is on the left of the blue pointer relative to the center of mass. So you know that you can forbid, for example, this triangle formed by these three vertices. Okay, and you continue. So you consider all vertices in counterclockwise order. You keep track of the green pointer. And doing this, you can remove every triangle that does not contain the center of mass. Okay, so this is solution. Simply 2 pointers once you have sorted the points accordingly. But then there's the first step, which is to get rid of all the possible bugs, which are very numerous. Okay, so first, if you only use floats or doubles to solve this problem, then you will have a problem when you have to recognize vertices that are too far apart, that are exactly opposite, corresponding to the center of mass. Then if you use floats, you will be stuck on this. But you cannot also use an exact representation of rationals, because if you do so naively using, for example, long int, well, you will also get stuck because then it will go out of bounds. So how do you do? Well, actually, you do a bit of both. You use the doubles when it comes to sorting, and then when you have to check if if 2 points are opposite to the center of mass, then you can do exact thing, or do them modulo big prime. Or maybe you can also use Python, or maybe you can use integers on 128 bits, or maybe you can use a big int or things like this. There are a lot of possible ways to do it. Okay, but there are also a lot of strange edge cases. For example, there are edge cases with center of mass maybe on an edge, but also the worst edge case is that there is actually a case where the center of mass can be one of the points in the data set, and then you will probably get a runtime error or something like this. And similarly, points may be aligned with the center of mass or something like this. So there are a lot of edge cases, and you have to get rid of them. Okay.
Last problem in order. So before the freeze, there's no one solved. Actually, no one submitted before the freeze. So, but I'm curious that, is there any teams that really spend at least half an hour thinking of this problem? Can you raise your hand? Okay, there are some teams. Good. So actually this problem, I would say it consists of 6 or 7 small questions. So if I present these 6 small problems, so for example, it's in IOI, it has 7 subtasks. Maybe it will be easier, but here is ICPC, and it only has 1 problem, so I take out all the stairs. Yeah, so first question is, maybe you know, okay, only knowing the pre-order and post-order cannot determine a binary tree. You know, if we know the pre-order and in-order, or we know the post-order and in-order, we can determine a binary tree. I think you might know that, but only pre-order and post-order you cannot determine. But how much you can determine it? You can determine to the following extent. You can determine like this. It means that if some node only has 1 child, okay, you don't know its left child or the right child. But if some node has no child, okay, you know it's no child. It's nothing to tell. But it has 2 children, then it's determined. So we can determine the tree into this level. And okay, now we have 6 subtasks. So first subtask is, if none of the in-order is known, how many possible in-orders are there? Answer is simple because we see the green links. Or this unknown, it's two possibilities. So it's 2 to the power of number of nodes with one child. Okay, then the subtask 2 is if only root's position is known. Okay, one node, which is the root, you know the position. Then what happens? You see in order, it's at the root, it's the leftmost or rightmost. Then you know the root's child, is the root's left or right location. Okay, we get one more information. So if we, then it's the 2 to the power of number of nodes with one child minus 1, because we know the root. So question 3, if there are 2 nodes, we know 2 nodes position in order. For example, the green is the root, and another is the red one. We know these two, they are neighbors. First the green and the red one. If we know 2 nodes position, how to solve this problem? Okay, the answer is we can determine the tree to the following extent. It means from this non-node to the node, all these yellow links, it's determined. I won't say it's left or right, but you can prove it's determined. Yeah, and also this green, this yellow's its own child, it's left or right, it's determined. Okay, so subtask 4. If the root and multiple nodes position are known, what's the how do we know that? How much more information do we know? So because we don't have enough time, I will tell you the conclusion is for all known nodes, all ancestors, including themselves, if it has one child, means it's like the yellow link like here, their child left-right location is determinate. So in this case, if a few nodes in order are known, including the root, then all their ancestor and themselves left and right position are known. Then you can do some minus here, 2 to the power of number of nodes with one child minus these cells. Okay, so now until the 4th subtask, we discussed the situation that if the root is included in the known nodes. What if only one, the 5th subtask is, if only one node, x, which is a random node, it's not necessarily the root, only we know this red node, how do we solve it? Okay, then if only x, so the answer is like this. I don't have time to prove it. The answer is only x itself and its ancestor's child left or right location are relevant to its position in order. So only these red lines go to yellow links are left or right. It's relevant to its in order position. For example, here, this black one, it's left or right, doesn't matter. Combination means, imagine at the beginning, all the yellow links are going to left, and we push some to right, push this to right, then the position in order will go 1 in right. So we have 10, for example, we have 10 yellow lines to push to right, but the actual position, only we need to push 4 of them. Then it's the combination C10, 4. So we need to calculate combination. Actually, it's the 2 combinations, the sum of 2 combinations. Okay, the final, we go to the final subtask. If there are multiple positions are known and may not include the root, we invent a root, which means because this is a continuous part in order we know, it means there must be a single node with a maximum height in this continuous part of the order. You can prove that. So what does it mean? It's not possible to have like this while these known nodes are consecutive. It's not possible. Due to the time limit, I won't prove that in this room, but if you know that, then the problem is two parts. One is as if this is the root. We've already solved the problem with the root. And the second problem is this position, this root position with a combination. So these two parts, we times them together, we get the result. Yeah, thank you.
Okay, so I hope that everything is in order for you now to ask us questions, because this is the end. So if you have any questions about the problems themselves and not about any other relevant and important topics that I can't answer, please ask them.
I think everyone wants to go to the resolve now.
Okay.
Yes. And yeah. So I hope that you all had this strange mixture of liking and hating the problems, and that you all had this mixture of being happy and frustrated, because this is really the spirit of ICPC. Like, I really hope you had this feeling. Because, yeah, I mean, yeah, we learn, but we are kind of masochist, really. But now let's go. Okay, what happened now with the last, during the throws, right? Oh, we want to see how the winners are. Oh, okay. So by the way, what will happen now? We will show the standing like it was in the freezing, and just play what happened during the last hour. And then we will see teams that will maybe go up or down, and then we will see the final rank of the teams. This is what we will see, okay? And okay, and here's a chair, and here's a table, and here's a cupboard. Okay, this is funny in French. Je meuble. I don't know how to say in English. It's not fun. It's not funny. Funny, and now we can almost start. Yeah, start. Okay. Yeah. Okay. No, yeah. All right. Let's start. Yes. Okay. Whoa. And by the way, when we arrive to the medals, then I will tell people come here also with sponsors, and we make photos. And it would be good if at that moment we have for some volunteers, we can bring roll-up posters here on the stage. They should actually be on the photo then. Yeah. And now let's start. Okay, good. All right. Oh. Okay. Now, okay, this was in the freeze, okay? This is all the standing of the freeze. Okay. It's a bit long. It's long. Okay. A lot of teams. Okay, let's start from the end. All right. 108 teams, right? 103. Okay, 103 teams. How come? No, because they're ex aequo. Okay, good. XArg, will they be able to solve No. Okay, no. And T3P, will they be able to solve E? No. And F? No. Okay. Innomate, will they be able to solve? No. Okay, and no. And the next one, the I? No. Okay. Oh, too bad. Okay. B for Control Shift Complete. And F? No. Oh, too bad. Bagoo. A. Come on. Oh. And G? No. Oh, okay. Space limit. Oh. Okay, and yes, G, no, and X, code, yeah! Oh, wait, bravo. Yes, and Praline, yes, F, G, no, okay. Oh, no. Recursive or not recursive? Yes. To do thing name, E, no, and, okay. Polynux, no, will they have, no, 418 empty bot and D, no, Ada, okay. Let's see. Whoa, good. Yes, and the other one, the last one, okay, 2 problems solved, okay. Next one, whoa, thank you. Okay, bravo. Okay, next one. ITI 3, and, okay, they're done, okay. And LG, LMO, no, and ENT plus plus. Yeah, oh, wonderful, wonderful. And now, okay, actually, and this one, and now the K, no, okay, we're still in the two problem teams. They solve two problems. And now NSPC2. Oh, good, very good. New York Tech and B, oh, wonderful. Raise the C, and will they, no, okay, and the last one, K, oh, no, okay. Pardon. And H, oh, nice. UTC code, will they have E? No, okay. TNT plus, the A, no, and the E, yes, very good. Praise the snake. Will they have the K? No. And here J, K maybe? No. Okay. UPCGM will, no, okay. Midas accepted. Okay. E. Oh, they have a lot of pending. Well, will they, okay, will they get one more? Yes, three problems solved. Very good. Minus back, and one, no, okay. Checkmate, coders. Let's see, B, and then they E, they tried a lot of things, right? H, no, J, K, okay, Genova. E, okay, Uniboys, B, and then E. Oh, good, very good. All right. Sobonor. Oh no, okay, three problem solved. Sea Lions, A, E, and K, no. The La Stale Red, E, and K, yes! Oh, so good. Okay, C minus, D, oh, wonderful. They have one more maybe pending. Montpellier B, E, and K, no, okay. Min C, okay, A, okay, and the E, will it work? Yes, okay, good. Nordheld, B, no, and E, no, okay. Oh, they have a lot of pending, no? Let's see. Okay, B, C, D, okay, come on. E, oh, come on, G. Yeah! Okay, another, okay, ENS, IPC. J, oh, IMT, B++, K, no, and New York Tech, G, and K, maybe, no. And pardon, again, we saw them, the last, oh, really good done, bravo. Dynamic Lice, no, and Unitop, okay, top means go up, no, come on, NT++, okay, there's nothing pending, Uniboys, okay, 3 problem now solved, Barbacoa mix, okay, oh, good, oh, very good, C minus, maybe one more, okay, mine Paris 1, B, and L, no, okay, good, Mida accepted, no, C is lost masses, oh, you'll see them again, Topo Boys, no, and J, oh, good, very good, and bad code, hexadecimal, yeah, up, yeah, good, and La Stale Red, okay, Minon C, nothing pending, Euphoria, A, no, ECL2, no, un croissant muy bueno, A, E, oh, good, and polycotomy, no, and, okay, I don't pronounce, please, the team name, and check, oh, no, and net 7, okay, what happens? Oh, yeah, they solved the first problem, yeah, right, very quickly, huh? I mean, congratulations, yeah. Problem I mean, this was impressive. Okay, net Turing, maybe E, no, and maybe K. Come on. No. Okay, transform name est Fourier and yo, one problem solved. Okay, cataphorisme lui-même, A, and maybe E. No, okay, maybe K. Oh, good! Woohoo! And ITI 3. Okay, very good. Chicken wings, G, and no, and J. Yeah, very good. Université Rennes, team 1, E, no, okay, J. Oh, no, okay. Bimbi di Turing, A, no, and J, no. Using namespace, B there, E, Oh, yeah. The linksgang E. No? Okay, L. Oh, there are not many people tried L, and they've succeeded on L. This is good. Pika doesn't. A. E. K. Okay. ENSPC 2. Like, but now we're in the 4-problem range, exactly. Like, yeah, they're all solved problems. I mean, it's impressive. I need a week to do one. Okay, next one, and now? Topo boys, okay. And bad code again, oh, no, NPU up. Bad code, the last one, K. Oh, good. Oh, very good. Very good. IT 355, now they did one more pending. No. Transformer Esta Fourier, one more pending. No. Cataphorism, there's nothing. Okay, one more pending. No. Okay, but 4 problems now is very good. Like we're in this category. UNSREN A, and then maybe E. No. And toujours un des C. Yes. Linux gang with 4 problems now. Sapienza Red. Yes, very good. The top of the mountain, of course. No, but Insados, you see. Un código mejorable. And K. Oh, very good. Okay, now top of the mountain, ECL1, yes. And Caravana Fighters, A. Oh, again bad code. Now this is their standing. Now we are in 5 problems solved of these teams. Like this is impressive. Toujours un DC. Oh, un código mejorable. Fusili. Yes. Unit sent notes. Sapienza Red. L. Insados. Oh, good. ECL1. Team sort. Oh, good. Caravana Fighters. Yes. Using long. Yeah, B. They solved B. Inside A and B. No. Okay. They. No. Wait. They solved. Maybe some electricity. All right. Montpellier. Oh, good. Toujours un DC. Now there are 6 problems now. Every in the 6 problem category. This is something. Caravana Fighters. No. Fusili. They are done. Check. They still have B. Oh, good. Oh, good. And E. Team sort. Okay, they are done. ENS space. Very good. Like this is a final statement. Standings. Galaphomatic. G. C. No. And L. It's interesting to solve L. Like this is a unit code Dolphins. Université Montpellier A. ENS Ulm 2. Oh, good. ENS ICPC 1. L, yeah. Okay, this L gives a lot of price now. Technicode. Overkill TO. Oh, they got very high, 15 rank now. Okay, double IT think. Check one more. Oh, wonderful. Belinda San Angeles. Wow, yeah. Sapienza Black. Okay. ENS Sheep. No. INT Greatest Okay. In-laws, they have L. Oh, good. NSL1, they have one more. 8 problems solved. Come on. NSIPC 1, Technicode. G. No. Masters of Breaks. Okay, 7 problems solved. Now we are in this category. Now M. Okay, it's interesting to solve a problem that not many people try to solve. H, like this is good. Double IT think. E and L, okay, very good. La Stalle Blue. D. Ho. Porpon pourpre. Des C. No. L. ENS Ulm. C. Oh, very good. Flagtan. C. No, there's a lot pending here. Huh? D. There are a lot of pots on the and first to solve what again? The first solve A, yes. Very good. That's like a special award, yeah. All right, now let's continue. Now we're getting very close to the medals, you see? EPFL Olympiads, D, G, and they go up. And check one, Melinda Angeles. Okay, now 18. They're promoted to European Championship. You're going to Prague. You're going to Prague. All right, all right. So buy your plane, your train ticket, please. Okay. Now, let's continue. In assume 2, one more. In-laws. Wow! Tautology. Oh, 9 problems solved. This is amazing. 9 problems solved. Double think. Okay, this is their setting. Like 16. Okay, 16, and they're the first to solve the problem J. Like this is impressive. Like a special applause for them. ETH Zurich, you rock. Okay, EPFL Olympiads 2. Okay, so did I solve C? No. And did I solve G? No. Okay, L problem solved. Like La Stalle Blue. Did I solve G? Did I solve G? Did I solve G? What happens? No, and L? Woo! Okay, but stop now. Okay, bronze, stop, let's stop. Ça s'arrête tout seul? Ah ouais, okay. Okay. So, bronze medalists, please come to the team with your coach. You're getting the medals. And sponsors, you want to come please also be on the photos. Okay, now I have to explain something. Those that get prizes, no, they get medals, and then everyone that get medals, you get later to the booth of Huawei. They have a special prize for you, and you go also to the prize of JetBrains. They also have a special prize for you, like Burgos, like really, yeah, very good, very good. Okay. La 4. Yeah, come on, just help us, like everyone taking. So those, and we have those also. Like for yeah, okay. You get a lot of things now. Andre, please come on the stage also for the photo. Okay. Yeah, yeah, and. Is there someone from Huawei also on the photo? Okay. Is there someone from Huawei on the photo also? Yes. Oh, I liked it so much. All right. Yeah, okay. Okay, big applause for our bronze medalist. All right. Can we have a little bit more light here on the stage, here in the middle? Okay, next one. Okay, thank you. Let's continue. We have a still, but your sponsors, you can stay, yeah, please. Okay, next one. The next one, let's continue. Okay, let's do one. Will they solve one? Yes! Okay, then we're reaching someone pourpre. Ho! Okay. Any problem, someone poop. Please come on stage. Okay, we are so proud of you. And I'm so proud of you because I'm one of the coaches. Okay, can you help me with the prizes? Yeah. Oh, je suis tellement fier de vous. Peut-être mettez-vous là, comme ça, en face, je vais les mettre comme ça devant vous. Attends, je vais vous mettre 2 là, je vais n'importe quoi. Ok. Moi, je prends un aussi pour moi. Huh? Okay, thank you for your helping. Yeah, this is for, yeah, maybe. Okay. Oh, so good. Here, a big applause for our bronze medalist.
Sylvia.
Yes. Big applause. Okay, even more. Okay, very close family here. All right, all right, all right. It's like a photo studio. Can you have some makeup, please, also? All right, thank you. Non, non, le mets ici. Et après, vous allez au... Next one. Now, let's continue. Let's continue the unroll. Okay, UPC 2. Okay, 2 more problems pending. And 8. Oh, very good, very good. 9 problems solved. UPC 1. Whoa, 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 whoa. Now it gets, who will get the next APF Olympiad 1? Oh, what a suspense. I mean, there are a lot of things happening here in the last row. And see, oh, I mean, it's, this is really a race here. And M, oh, it would have been done good, like, okay, 12. Okay, now, bronze medalist. You're going also to Prague, okay? Okay, can you help us with that? Yes. Oh, good, you put those. Okay, maybe I can get this. It's just for the, to put the medal afterwards, right?
Thank you so much.
Okay, and later on, don't forget to go get your present from Huawei and from JetBrains, right? Yes, and we heal that. Okay, good. Good or not? Okay, thank you. Thank you again. Okay, let's continue the unroll. Ah, yes. And now it's next one. All right, all right. All right, so now let's see. Tautology. Okay, 9 problems solved. Okay, they are 11, rank 11. Promoted 9 problems. You're going to Prague as well. I mean, it's very impressive. Please go on stage now. With your coach, you're getting the medals. Okay. Bravo, bravo. Well done. I mean, this is impressive what you did here. Where's the coach? Ah, yeah, here. Danny, oh, Danny. Nice seeing you. Okay. Okay, thank you. Big applause for them. Okay, we continue the unroll. Okay, Unisilm 1. Okay, so this is their level. 9 problems solved. You also have a bronze medal. You're pronounced to the European Championship. On stage, please, with your coach. All right. Where do we have team? Oh. Ah, you're ready. Whoa, cool. Oh. It's really teamwork, like here. Okay, just stand here. Yeah, big applause for our Nesul. Adrien, bravo.
Merci.
Hein.
Je
bravo,
passe,
bravo.
c'est bon.
Bravo, bravo. Okay. Thank you. All right. Okay, thank you. Ouais, tu peux. Ouais. Okay. Next. What happens now? ENS UPC 2, and they get also the European Championship. Solve 9 problems, and they're the first to solve problem H. Okay, big applause for Catalonian contestants. Bravo. Yes. Okay.
Thank you. Oops.
Yeah. Well done. Thank you very much. I should have bought a bigger size, huh? Yeah. Take one for your coach. You bring it home, right? I mean, he will be happy. All right. We are good here in the match.
Sorry.
Yes. Very good. All right. Thank you. You're all done. Bravo. All right. So we continue our resolve. UPC 1 against Sen University. They still have 2 problems on the fire. Yes! Rank 2! Imagine! Like, this is amazing. If they stay here, they're going to the finals, right? Uni boys, 1 more, and they go up. Woohoo! This is so crazy. EPF Olympiads 1, and okay, bronze medal. Yes. So please on stage, please. First to solve problem B, solve 9 problems. This now it becomes really impressive. Like, it was already impressive, now it becomes really impressive. Okay, please. Yeah, very good, very good.
Thank you.
And for your coach,
Thank you.
Yeah.
Great job.
Okay. Yeah. Oh, we changed the camera now, huh? Yes. Okay, good. Thank you. Big applause for them. Thank you. Let's continue. What happens now? CNX TV. Whoa, no. So much things are happening here on the top. And Volta gang. G? No. No. Okay. Okay, rank 7. This is the final rank. Very good. For bronze medalists, solve K problems. 9 problems, solve problem K. On stage, please. Well done. And for your coach to bring home? Yeah. Thank you. Okay, now let's continue. Like, there's a lot of things happening now. And exotic, they still have 2 problems. Something can happen to them. And see, woo! So many people go for the 2nd rank. And dethroners are not really dethroned, huh? Heroes of the Sea. D, one more. Yeah! Okay. And Uni boys. Okay, wow, 10 problems solved, 10 problems, can you imagine? Okay, you're silver medalist now, and you're promoted to European Championship. You're first to solve problem C. Like, okay, like, this is impressive. And there are 2 more, no? Ah, okay. Okay. And a present for your coach, huh? Silver medalist. Look at the prize. Look at the smiles. Like, this is very beautiful. Like a big applause for them, for the boys. Woohoo! All right. Thank you. Let's continue. Okay, we unroll. Okay. Suspense, UPC 1. One more problem to solve. G, and. Ah! No, okay. But really, like, this is impressive. Like, 5th place. Okay, on stage, please. Silver medalist. You are going to Prague. Oh. And this is for your coach.
Thank you.
Well done.
Okay. All right. Oh, look how happy they look. I mean, really, they can be happy. And we are happy for them. Yes, thank you. Let's continue to unroll. What happens now? Okay, CNX TV, Polytechnique, G, they have the problem with G. Will they solve it? Yes! Woo! It's amazing what is happening now here on the top. Exotic. One more problem on the fire. 8. No? Okay. 4th place. I mean, this is impressive. Come on. 10 problems solved. On stage, please. All right.
Thank you. You notice how we didn't qualify.
Exotic.
Good job, guys.
Thank you.
I mean, good job.
Thank you.
Wow, this is impressive. For your coach, huh? Bring that for your coach. Yeah, get in the light a little bit. Get a bit back. Okay, this was impressive. I mean, we are really impressed of those students like here now. Okay. A big applause for Exotic. Yes. Thank you. Oh, let's continue the unroll. Heroes of the Sea. 2 problems still on the fire. G. Come on. Okay. Come on, it's amazing how many people switched on the place C, no? All right, let's continue. CNX TV. And, okay, silver medalist, rank 3, solved the problem C, and also solved 11 problems. Okay. But you permit
Yeah, I can do it.
Okay. You're also tall here, or I'm so small, huh? Thank you. Can you give it for Hangzhou? Okay, what a day. Like a big applause for our team, Exotic, I think. Yes, bravo. Okay, thank you. Okay, thank you. We take this? No, this you go back. And something else happening? Okay, we're done. Okay, we have to wait something? All right, let's wait. Ah, for the photo. Yes, okay. Okay, let's do the photo again. I have to say the sentences before. I don't remember what I said. If you replay everything. All right. Thank you. Okay. And by the way, okay. So now we are getting on the gold medals, all right? Gold medals, come on. Okay, what is happening now? Okay. What happens? Woohoo! Heroes of the Sea, 2nd place. Pretty impressive. You are going to Kazakhstan.
Fantastic work, guys. Maybe they forget to coach and give the medal to them. Thank you very much.
Should I put it on the mascot? Like this is.
It was my request.
Yes, very nice. I mean, come on. All right, gold medal. Look what the prize they get. I mean, yeah. Okay, big applause, big applause. Okay, bravo. Okay, and finally, dethroners. How many problems they solved? How many problems they solved? Huh? 11 or 12? What is happening? Okay, 11 problems solved. Okay, very good. Very small penalty. Okay, on stage. Yes, yes. Okay, here, please, here on stage. And you're not only getting the medal, you're not only getting a big applause, you actually get the trophy, okay, the SWERC trophy. I mean, oh, wow. Wait. Yeah, do you have one more hand to hold the trophy? Come on, it's very heavy. I help you. Okay, good, guys. Yes. Okay, our winner of SWERC. A big applause to everyone. Okay, thank you very much. Like this was very impressive. Okay, it's heavy, huh? You can take it home, or if you find it too heavy, you can leave it here. I'm not offended. You can take it. Very good.
About the prizes from following JetBrains.
Yeah.
He wanted to do it.
To recall?
To collect, because they didn't know that they can collect it.
Yeah, I will recall, yeah. Okay, thank you. And now very important announcement. All the people here that got medals, they go to the Huawei booth and to JetBrains booth, and they will get a present, like a personal present. Okay? This present that you have seen here. Okay? Very good. Now I have 2 more things to show, and then we can all go home. Yes.
I have to go up.
Yes.
Yes?
Yeah, we're done now.
Yeah.
Exactly.
Closing speeches from JetBrains and from...
Really?
Yeah, just
It's
1 minute.
But we have the video also, no?
No, but the closing speech takes a second.
Okay. So, okay, just a recap. Who continues competing in the ICPC? It was said already, but just a small recap. Okay, on those, the first 3 teams, they go to the final. They have the red star. And, okay, and 13 teams, they have the blue star. They go to the European Championship, right? And, okay, what is happening? Is it not your surprise or what? Okay, the rule is from every institution goes to the finals. What? Yeah, the rule is that the best institutions go to the finals, and so like they can send one to the European Championship. So Ecole Polytechnique 6 sends one. Okay, and these are the rules. And now we are very happy, and now it's time to thank our them. All our helpers. The parentheses now? Yes, okay, very good. So, thank you very much. The weekend is over now. It was quite impressive weekend. It was not possible without the help of a lot of people, people, especially the sponsors that pay to all of them, which are JetBrains, Huawei, Jane Street, Bending Spoon, One Point, Meritis, Hexali, CNES, CFM, IRI, Lipsy, Sorbonne University, CNRS. Big thank to all these sponsors. We really appreciated your help. Now let's show the videos again on some new videos of those sponsors.
Any patience? I think it's adventure.
I think it's dedication. It's dedication and also loving to solve problems.
Be able to put in the hard work to study and prepare for this competition.
It's hard work. It is effort.
There is a lot of smart people in the world, but few of them are persistent.
Hi, I'm Ignacio. I'm 21 years old.
My name is Mateus Aires. I am from Brazil.
My name is Xu Wen. I'm from Zhejiang.
My name is Bernard and I'm from Iceland.
My name is Zhen Zihao. I'm a grade 3 university student from Tsinghua University.
My name is Masaka Yoneda.
My name is Hirotaka Yoneda.
You're at the ICPC Challenge Championship powered by Huawei. We are facing huge challenges just waiting to be solved by best of us.
The business of helping people prosper, for there to be enough and more than enough.
I'm excited to see what will Huawei bring us next.
I am very excited for the contest.
I'm excited and a little nervous.
I feel a little nervous because it is the first time in this year to participate in a big contest.
I have experience to get second place in international optimization contest.
I also aiming to become top 3.
I think I will get into the top 10 because I get the top 10 in the previous content.
These type of challenges are really hard.
When I join a competition, I don't like to lose. I usually join to win and I want to come at first position.
Mostly known for 5G and like internet related stuff, but we got to know that they're also doing like some solutions for car, and I found that quite cool.
There are a lot of high technologies in Huawei.
They have a lot of products over all sorts of businesses, and it's a very large.
I thought that they are doing for the scientific innovation for the society.
We see that Huawei is very committed with doing better, with improving and with innovation.
Because Huawei is a name that people trust to provide their communications and services. And that's actually why I'm right here at headquarters in Huawei.
I made the result a bit better of him.
I finally got 31st place.
Not very well. I got the 18th.
Today I got 14th place, and I think I'm satisfied with that.
I won the competition. I was first prize because I got some recognition of some very good people, so I was happy about that as well.
Huawei problems are really focused on real life, so I think it would help people in the future.
The problem is buffer sharing and reallocation problem. One of the bottlenecks of computer speed is about memory. So, what happens if computer speed is going up? Not only our computer becomes fast, but we can do many research.
It can improve self-experience of using cloud services.
We're doing it together with industry and community leaders in the small and in the large. And I think that's one of the reasons why Huawei loves to be part of the competition. So we have training camps in a lot of different ways, and actually Huawei sponsors some of those training camps, and also challenges where we introduce problems that don't fit the ICPC model of competition. The ICPC is about creating opportunity for others. That's what I mean by flourish.
Hello, everyone. Congratulations to all. I know it's like Christoph has mentioned, it's mixed feelings. We're all excited, we're all sad, we're happy looking forward. We don't want this competition to end, but at the same time, we're all very tired. So again, we would like to congratulate everyone, and just a couple of small announcements. For the winners, there are special prizes provided by the global ICPC sponsors, Huawei and JetBrains. So their teams will be waiting for you at the booth, at the career fair, so don't forget to pick up your prize before you leave. And for the others who didn't win the medals this time, you can still come and see and talk to them because they have a lot of great opportunities for all of us. And before we conclude, we have, of course, a special round of thanks to all the volunteers who have been with us day and night, not only these 2 days, but for the past couple of months. So let's give a huge round of applause to all the volunteers. To all the participants, all of you, let's get a big round of applause to yourself, because not only it's been an amazing work on this weekend, but we know how hard you were working on during the year to get it to this event. So congratulations to all of you. And a big round of applause and thanks to our global sponsors. And I would like to invite the speakers whom you may already know for the shortest speech in history. We have a couple of speakers who would like to say a special thank you for you. I would like to invite Denise Bardou, the lab director of Huawei CSI in Paris, for a thank you word.
Okay, I will make it short also. So, okay, as we conclude this 2023 SWERC in Paris, this event has showcased the brilliance, the dedication, and the passion of young talents when facing challenging problems in algorithmics and programming. So I express my whole congratulations to all the teams that participated. Your problem-solving skills, teamwork, and resilience under pressure, time pressure, has truly set a standard for excellence in the field of programming. It's inspiring to witness the creativity and innovative spirit that have unfolded during this competition. I would like to express also my deep thanks to the organizing committee, to the volunteers and to the jury, and all who worked tirelessly to make this large event a success. So thanks a lot. Your commitment to fostering a lively community of problem solvers is impressive. And so at Huawei, we are proud to support ICPC. Indeed, the skills and knowledge displayed by the participants align with our commitment to contribute to the development of the next generation of innovators and tech leaders. And this event definitely builds a talent ecosystem involving both industry and academia. So let's continue to celebrate the spirit of innovation in algorithmics and more generally in computer science. At a time where generative AI can generate code from prompt, so there is still a dire need for new innovation, new research breakthrough in computer science, coming from sharp and bright minds able to cope with particular difficult challenges. So the challenges arise from academia and industrial context both. I'm sure the skills you have demonstrated here not only open your doors to your next exciting academic curriculum, but also will give you more opportunities for academic and industrial careers. So to conclude, I want to reiterate Huawei's commitment to supporting such initiative and building up a talent ecosystem. We look forward to seeing the contribution each of you will make in the world of technology in the future. So congratulations once again, and may your passion for programming and problem solving continue to light your path in the future. Thank you.
Thank you, Denis. Thank you again. Again, if you're interested to meet Huawei, looking for an internship in Europe or abroad, he's one of the best persons to talk about it at the career fair. And now I would like to invite the very long-term supporter of the ICPC community, the person whom you may all know because he is really famous in the ICPC community for the shortest speeches ever. He doesn't need an introduction. I would like to invite the Vice President of JetBrains, Andrei Ivanov. JetBrains has been a long-term supporter of the ICPC community. The CEO of JetBrains was one of the participants many years ago. So welcome, Andrei. Thank you so much.
Thank you, Nika. First of all, I would like to thank all of the organizers because it was a great event, and I know how difficult it is to organize such a great event for so many people. So thank you very much. Also, thanks to all of the participants, because this was one of the most closest competition and competitions that had the biggest intrigue until the very end, because you've seen how the results were unpredictable until the end. In the middle of competition, we were sure that the team that actually won would win with no doubt. And in the end, we wasn't sure, because there was this problems still not solved. So very interesting competition. Thank you to everyone. And thank you to judges for the great problem set. The usual criteria of a good problem set is that everyone solved at least one problem, which is not exactly the case here, but another one is that nobody solved all of the problems. And this is a definite success. I hope you guys who tried the problem M wouldn't see it in your nightmares after that, especially after the solution was presented. So, excellent competition. Thank you very much. I had a great pleasure to be here and to see all of this. To those of you who qualified for the final and for the European Championship, I wish you all the luck, and we will see you there. And for those of you who didn't graduate, it's not the end of the world. You did a great job anyway. Thank you.
And a special thank you to Jane Street and Bending Spoons for being the supporter of SWERC and providing such great prizes and opportunities. And of course to Sorbonne University, the host of this time event. Thank you, Christophe.
All right. I would like to thank the judges, Guillaume Aubion, Mehdi Bouaziz, Nofar Karmeli, Thomas Degnaud, Garance Gourdel, Yona Yenana, Vincent Juget, Raphaël Marinier, Omori Pouli, Rablo Rotondo, Philippe Schnebelen, and Cheng Song. They did very good job. Impressive problems. Thank you a lot for them. Thank you a lot for the volunteers. I'm not reading the name. I think most of you are gone already, but we will invite you in a week. We will do very nice dinner, drinking. We will do something together. We have to thank you again. I mean, yeah, very much. Thank you. And thank you to the organizers. I mean, the list is also very long. Okay, Antoine Genitrini, Bruno Scoffier, myself, Constantin Valentin Terzier, Emmanuel Chailloux, Gabriel Batti, Lydia Perovskaya, Letang Huang, Ang Yeo M, Magali Richard, Mehdi Naima, Michael Vasseur, Nathalie Picot, Nawal Benabou, Niha Mohan, Patricia Autier, Philippe Cadino, Théotime Lehelard, Vassil, Marianne Skotori, Véronica Soboleva, and Vincent Cuisin. You all did participated to this organization. You all had a role there. Thank you a lot. And that's it.
I think we missed the name Christophe Dur on this list.
Yeah, okay. Okay, thank you. All right. So, okay, go home. It's the end. It's the end. Thank you a lot.